The other type of series covered in this course is known as geometric series. And a geometric series is one where the consecutive terms are in common ratio. So let's look at an example of what that means. Let's say the first term is 2, and then the next term is 4. So to go from 2 to 4, we've doubled. So the ratio is 2 to 1 essentially. So the next one would have to be 8, so that from 4 to 8, that ratio of 2 to 1 remains. And then the next one would be 16, and the next one 32, and so on. So you can see that previously in an arithmetic series, when I went from one term to another, I would add a common difference. Now I am multiplying a common amount, or we have a common ratio of 2. So for an arithmetic series, we would do t2 minus t1, t3 minus t2, and we'd hope those differences were the same. Since we're interested in ratio, what we're looking at is t2 over t1, in this case 4 over 2, which is 2, to be the same as t3 over t2, which is 8 over 4, which is 2. And as you can imagine, as I continue, that's going to be the case. It's going to all be the common ratio 2. So let's come up with a general rule for the nth term, just like we did for an arithmetic series. So if my first term is a, then the next term would be a multiplied by that common ratio. Let's call that r. Then to get the next term, I'll take the previous term, ar, and multiply it by r. To get the next term, I'll take this term, which is now ar squared, and multiply it by r, and so on. So just like before, I'm going to make a list: t1, t2, and so on. And I'm hoping you can see the pattern just like before. When I have 1, I have r to the 0, 2, r to the 1, 3, r squared, 4, r cubed, 5, r to the 4. So Tn is going to be a r to the n minus 1. And that will get me any term in a geometric series. Let's have a look at an example. Now, since in this question they've already told me that this is a geometric series, I don't need to go and prove that it is. How do we prove if we needed to, if the question didn't say it was geometric? Remember, we need to take the second term divided by the first term, then take the third term divided by the second term, and show that those ratios are the same. I don't need to do that, so I can jump straight into finding the 10th term. Let's make a list of what we have. Our first term is 5. We're looking for the 10th term, and I need my common ratio. Now, interesting things happening here. My terms are going from positive to negative, positive to negative, and so on. The reason for that is, if I take the second term divided by the first term, I get negative 3. And of course, 45 divided by negative 15 gives me negative 3 as well. So the common ratio is negative. The impact of a negative ratio on a geometric series is those signs changing from positive to negative. If you go back and look at arithmetic series, the impact of a negative difference is that the terms are going to get, consecutive terms are going to get smaller and smaller. So let's write the rule down. Tn, a r to the power of n minus 1, substitute in T10, a common ratio to the power of 9, and that gives me negative 98,415.